Alright, we're going to begin today's lesson by going over our learning goal. Today's learning goal is that students will be able to use exponents to represent powers of 10. Remember that when you're taking your Cornell notes, this is going to go up in the top section of your notes. If you haven't done so already, go ahead and pause the video. On your graph paper, you want to go 5 spaces down for the first line and 5 spaces up for the second line, and then 10 spaces to the right to do the vertical line to connect them, give you the offset I. In the top section, you're going to write today's learning goal. As we've learned when we were talking about place value, we know that when you go from one place value to the next, if you're moving to the left, the values of the numbers are going to increase by 10. So if you go from the one place value to the tens place value, it's going to be 10 times larger. If you go from the tens to the 100s, it's going to be 10 times larger. The opposite is also true, so that if you go to the right, then each place value is going to be 10 times smaller, or we can also say that that is 1/10 of. So as we move to the left, we increase by 10. As we move to the right, we decrease by 10. We also found out that as we continued to the left, the numbers kept getting larger and larger and larger, and it took up a lot of space on our paper. We made a table of place value, and as we were doing the expanded form of some of our numbers, we saw that it took up a lot of space. So what we do in order to not have to take up space is we have a new way of writing some of these very large numbers. And the way that we do that is we use exponents. So we're going to talk about that on the next slide, where we actually identify what is a base, what is an exponent, and how do we use those to represent larger numbers. So if we had a large number like 1 million, we can represent that by writing it in exponential form. And the exponential form that we would use is we would have a 10, and then this little number that's raised up is a 6. That is called the exponent. So we have the 10 here, and then the 6 is an exponent. And that value is equal to 1 million. So the base, the 10, is the factor that we're going to multiply by itself over and over and over again. And the way that we know how many times we're going to multiply it by itself is we use the exponent. So if we have a number like 10 to the 6th power, we're going to multiply 10 by itself 6 times. So it's going to be 10 times 10 times 10 times 10 times 10 times 10. You can test to see if this actually works. So if you can get out a calculator or use the calculator tool that's part of that's on your computer, go ahead and type in 10 and multiply it times 10 times 10 times 10 times 10 times 10 and see what your answer is. And if you do it correctly, you should get 1 million for your answer. So what have we learned so far? When we have large numbers, there's different ways that we can write them. The first way that we can write them is in standard form. A standard form of 1 million is 1, a comma and 3 zeros, another comma and 3 zeros. We make sure that we include our commas here so that we know that we're representing each of the periods. The second way that we can represent large numbers is in exponential form, where we use a base and an exponent. The base is the number that we multiply things by, and we multiply it a certain number of times, and the exponent tells us how many times we multiply the base by itself. The third way is as an expression. So 10 to the 6th power, the 10 with the exponent of 6, would be the same thing as 10 times 10 times 10 times 10 times 10 times 10. And then the last way is in word form. And the way that we say this number, 10 to the 6th, is we can say the 6th power of 10, or we can say 10 to the 6th power. Either way accurately represents what that value is. The important thing that you need to know is you need to know that even though we can represent it in these 4 different forms, they all represent the same value. They all represent the value of 1 million. So we've already talked about how we can write a number like 1 million, but what do we do if there's another number at the beginning like 3? How are we going to represent a number like 3 million using our powers of 10? The way that we're going to do it is we're going to write it in expanded form. The expanded form of 3 million is 3 times 1 million. And then we're going to change the standard form of 1 million to its exponential form, which is 10 to the 6th power. So when we combine that all together, we're going to have the 3 that we started off in the expanded form, and then we have the 10 to the 6th to represent the 1 million. See how this is much shorter to write than it is to write out either 3 million or 3 times 1 million. So that's the purpose of being able to use our exponential forms, is to make those numbers smaller. So let's look at an example. Go ahead and write the number 80 million as a whole number times a power of 10. Pause the video while you're working on this problem. Okay, for your second problem that I want you to do, I want you to write 80 million in its expanded form. An example of the expanded form is up here. So how would you write 80 million in this form? Again, pause the video while you write that down. Our third practice problem, you're going to write the value of 10 to the 4th power, or the 4th power of 10. What value would that be? Write that number in standard form. And the last of our practice problems that I want you to write is write the value of 6 times 10 to the 3rd power. Change it from exponential form and write that in standard form. All right, so check your answers. See if you got that correct. All right, well, this concludes our video for tonight. Make sure that you have your Cornell notes completed. We'll be checking those for homework tomorrow in class. Thank you for joining us, and have a great evening.